if I told you that the mind-bending portals from your favorite sci-fi movies might actually be hiding in the fabric of space itself right now? While Hollywood shows us heroes stepping through glowing doorways to travel across galaxies in seconds, the real science behind wormholes is far more incredible than any movie could capture. Picture this: you're watching Thor casually hop between worlds through rainbow bridges, or Matthew McConaughey diving through a swirling vortex in Interstellar. These scenes feel like pure fantasy, but here's the shocking truth that'll blow your mind. The mathematics that govern our universe actually predict that these cosmic shortcuts could exist. Not as glowing portals with convenient handrails, but as mind-bending distortions in the very fabric of space and time. Let me take you on a journey through the looking glass of theoretical physics, where the impossible becomes mathematically inevitable. We're about to discover why Einstein's own equations accidentally predicted these cosmic tunnels, what would happen if you actually tried to use one, and whether humanity might someday surf through the universe on waves of warped spacetime. The story begins in 1935 when Albert Einstein was grappling with his greatest creation, general relativity. Working alongside Rosen, Einstein stumbled upon something extraordinary hidden within his own equations. They discovered that black holes might not be the cosmic dead ends we imagine, but rather one half of a bridge stretching across the universe. These theoretical tunnels, now called Einstein-Rosen bridges, represented the first scientific foundation for what we now call wormholes. But here's where things get mind-bending. Einstein's equations showed that space and time aren't rigid structures but flexible fabric that can be stretched, compressed, and even folded. Imagine taking a sheet of paper and poking two holes in it, then bending the paper so the holes touch. Suddenly, what was once a long journey across the paper becomes a single step through the connection. This is essentially what a wormhole represents in our universe. The mathematics are beautiful and terrifying. Einstein's field equations predict that massive objects create dips in spacetime, like bowling balls on a trampoline. But under extreme conditions, these dips could theoretically connect, forming tunnels that link distant regions of space. The entrance might be a black hole, but instead of leading to certain death, it could open into a white hole somewhere else entirely, spewing out matter and energy in a cosmic fountain. However, before you start planning your intergalactic vacation, we need to confront the brutal reality of what traveling through a wormhole would actually involve. The gravitational forces near these cosmic tunnels would be absolutely catastrophic. We're talking about tidal forces so intense they could stretch a human body into a thin stream of particles in milliseconds. The technical term is spaghettification, and it's exactly as pleasant as it sounds. Even if you somehow survive the entrance, the journey through the wormhole presents another nightmare scenario. The tunnel itself would be incredibly unstable, constantly collapsing and reforming. Without some form of exotic matter to hold it open, the wormhole would snap shut faster than light could travel through it. You'd be trapped in a collapsing tube of spacetime with nowhere to go and no way back. This brings us to the exotic matter problem, and this is where science fiction crashes headfirst into scientific reality. To keep a wormhole stable and traversable, you'd need matter with negative energy density. This isn't just rare, it's something that might not even exist in our universe. We're talking about material that literally has less energy than empty space itself. Current physics suggests that even if such matter exists, you'd need quantities measured in stellar masses to prop open a wormhole big enough for a spacecraft. The energy requirements are staggering beyond comprehension. Creating or maintaining a traversable wormhole would require more energy than entire stars produce over millions of years. We're looking at engineering projects that would make building pyramids look like assembling toy blocks. The civilization capable of constructing such structures would need to harness the power of entire solar systems. But let's imagine for a moment that these obstacles could be overcome. What would wormhole travel actually look like? Unlike the instant teleportation shown in movies, the journey would still take time. You'd accelerate into the throat of the wormhole, experience the bizarre physics of negative energy, and emerge at your destination having aged normally. The real advantage wouldn't be time travel, but the ability to bypass the vast emptiness between stars. Recent theoretical work has revealed even more fascinating possibilities. Some physicists propose that microscopic wormholes might be constantly forming and dissolving in the quantum foam of space itself. These tiny tunnels, smaller than atomic particles, could potentially be artificially expanded using advanced technology we can barely imagine. The implications extend far beyond transportation. Wormholes could theoretically allow communication across vast distances, create closed time-like curves that bend causality, or even provide windows into parallel universes. Each possibility opens new questions about the fundamental nature of reality itself. Current research focuses on detecting signatures of natural wormholes in space. Scientists are developing methods to distinguish between black holes and potential wormhole entrances by studying how light behaves around these extreme objects. While we haven't found any yet, the universe is vast and full of surprises. The gap between science fiction and scientific reality remains enormous, but it's not insurmountable. Every impossible dream of the past, from flight to space travel, began with mathematical equations and determined dreamers. Wormholes represent the ultimate frontier, where the boundaries between physics and imagination blur into possibilities we're only beginning to understand. So what do you think? Are wormholes the key to humanity's cosmic future, or will they remain forever locked in the realm of theoretical physics? Drop your thoughts in the comments below, and don't forget to subscribe for more mind-bending journeys through the universe's greatest mysteries. Hit that notification bell so you never miss our latest explorations into the impossible made possible.